Let's do a side-by-side comparison between making a confidence interval for a population mean, which you have already done, and making a confidence interval for a population proportion. And we are just going to use our TI-8384 calculator to solve it. After you have determined that you are working on a confidence interval problem, the very next thing you need to determine is what type of data you are working with. For this class, it will either be quantitative data, because you are measuring each individual in the sample, or it is binary data, categorical with only two categories. But let's suppose you want to know what is the average length of all fish in a huge lake with lots of fish. You will be measuring each fish in your sample. So this will be quantitative data. The population mean represents the typical data value for the entire population. A confidence interval will give us an idea of its value. But what if instead you wanted to know what proportion of all the fish in a huge lake with lots of fish are largemouth bass? Well, now you are dealing with binary data. You are placing each fish in your sample into one of two categories, largemouth bass or not largemouth bass. You are counting how many are in the category of interest. Let's look at what our random samples will look like in each case. For quantitative data, you will have a sample mean and usually a sample standard deviation, since the population standard deviation is usually unknown. Let's look how different it is when we have binary data. There is no standard deviation and no mean, just the sample size and the tally of how many in the sample were in the category of interest. So for our quantitative data, we got a random sample of 50 fish, where the sample mean is 8.12 inches and the sample standard deviation is 1.76 inches. For our binary data, we got a random sample of 1,000 fish, and 412 were largemouth bass. Now, before we get started on making our confidence intervals, is there something we should always do? In fact, you should do this before you do any statistical method. We should always verify that the conditions have been met. Are they different for our two types of data? Yes, they are. In both situations, we have to have random samples. But that is true for all of the statistical methods. And in both situations, we need to have a normal sampling distribution. But these two types of data have different sampling distributions, which have different requirements that verify that they are normally distributed. The sampling distribution for the sample mean is normal if either the population being sampled from is normal or if the sample size is at least 30. The sampling distribution for the sample proportion is normal if the sample size is large relative to the population proportion. You will see different tests for this, but this is the one used in our textbook. And the sample size multiplied by p, the population proportion, multiplied by 1 minus the population proportion, greater than or equal to 10, where the population proportion p is being estimated using our sample proportion. Also, the population has to be huge. So huge that the sample size is less than 5% of the population size. So all of our conditions have been met. Now we can get to work. Let's do the quantitative data first. I will just do this on the calculator without talking because you have already mastered using t-interval, or you should have by now. We are 95% confident that the population mean length of all fish in this lake is between 7.62 and 8.62 inches. Now let's do the binary data next. We will be using one prop zint. Press the stat key. Press the right arrow key twice to highlight tests. Press the down arrow to scroll down to A1-prop zint. Press enter to select it. Enter in 412 for X. Enter in 1000 for N. Enter 0.95 for sea level. Highlight calculate and then press enter. We are 95% confident that the population proportion of all fish in this lake that are largemouth bass is between 38.15% and 44.25%.